learners, welcome back to Build Coders. This is video 5.1 of the System Design playlist. In the previous video, we spoke about HLD and LLD using the example of Instagram, creating both HLD and LLD for it, we understood it better. In this video, we are going to cover monolithic systems or monoliths. You know, every big tech system you use today, Instagram, YouTube, Amazon, started from something very simple, just one server. So the question is, if one server works, why do companies build complex distributed systems? And more importantly, why does a simple system break? Today we'll understand the journey from monolith to distributed system. But for that, we need to first understand well what monoliths are. Starting with what a monolith is, why is it good, when should you use one, and why does a monolith break? We'll finally end with understanding why is there a need to transition to distributed systems. So let's begin. What is a monolith? A monolithic system or monolith is an application where everything is built and runs together as a single unit, as one single unit. So let us create a simple mental model to understand this better. Picture a big box, right? Like one big box, and this big box does everything. Inside that box, you have your login system, you have payment, notifications, you have your database access, your logic, main logic. So all of this is interconnected, right? And this is in one single unit. So a monolith means that everything is inside one single system. You have one code base, one server, one database, right? So if I have to make an example architecture, it could look something like this. You have a user, server, database, and basically everything is inside this. All right. Now let us understand why a monolith is good. Simply because it is simple to build, right? For beginners, for startups, for small apps, monolith is perfect because it is simple to build. You just need one system you are building. You are working on one code base, one server, one database. It's easier to build, it's easier to integrate. So overall, it is simple to build. It's easy to deploy. It's easy to debug, and there is no complex infrastructure. So it's clear how monolith is good. But when do you use monolith? Just because monolith is good does not mean you use it everywhere. Specifically, when you are a beginner, you are building an MVP, or your system is small, or very important, you want fast iteration. These are the cases when monolith is actually the right choice, right? You're a beginner, or you're working on an MVP, you are working on a small system, or you want fast iteration in your system. That is when you use monolith. But if monolith is so good, then why does it even break? Right? Let us understand that. So obviously something is breaking, that means it is facing some problems. So the first biggest problem for a monolith is the traffic. See, because most systems start with monoliths. You never start your system creating a distributed system on day one. You always start with a monolith. But when things start breaking, you need to diverge, you need to adapt to the problems, and you need to find solutions to it. And that is how your design changes. So the first problem that will help you understand why we are transitioning from mono to distributed is your traffic. Because if you have an app and your app is growing, let's say your app has 100 users, it's working fine. Let's say it has 10,000 users, that's also working fine. But what if it has millions of users? then it will break. Because one server cannot handle that many requests. Your system will become slow, it will become unresponsive, right? Eventually, it will crash. And that is obviously undesirable, right? So, traffic is one big problem that comes with monoliths. The second problem is single point of failure. Single point of failure means if anything goes wrong, your entire system will go down because you have only one server. As we saw here in the architecture, we have only a single server, right? So if anything happens to this, my whole system goes down, isn't it? Right? Because everything is on one server. If that server crashes, your entire system will crash and you don't have any backup because this is a monolith. One system, everything in one box. If something happens to this box, your whole system is down. No backup, no failover. That is problem number two. Problem number three, scaling. Obviously, when I'm building an app, initially I'll not have so many users, so many requests, but as I scale, as I get more users to my application, I need to scale my system, right? Now, in monolith, scaling means upgrading the server. Basically, you have one server, you upgrade it. Now, what do you mean by upgrade? Basically, you increase the CPU, right? You'll put more CPU, more RAM. That is what upgrading is, right? Scaling is basically of two types: vertical scaling and horizontal scaling, right? Vertical scaling is that I have one server, let's say S naught, right? I have one server and I want to upgrade my server so as to scale my system. So how am I scaling my system? By upgrading my one single server, by putting more CPU, more RAM into it. But when I want horizontal scaling on my system, what I'm doing is I'm adding more servers. I had one server, I'm going from one server to multiple servers. S0, S1, S2, right? So you do not increase the capacity of one server. In fact, you add the number of servers in your system. That is horizontal scaling. And if you're increasing the capacity of your one server, that you are upgrading your server, that is vertical scaling. Okay. Now scaling is hard in monoliths because vertical scaling has certain limits. Obviously, how long can you increase the CPU and the RAM, right? It has limits. You cannot upgrade forever, which is why scaling is a problem when it comes to monolithic systems. Problem number four, deployment issues. Now, if ever, a small change, if you have one monolith system, you want to make a small change somewhere, it requires changing the entire system because everything in a monolith is in one code base. It is almost everything is dependent on every other thing, right? So if I have to change one thing, right, or if I have to debug that there's one small bug I want to change, it will affect my entire system, right? So basically, what that means is that one bug can break everything. Also, if I want to change something in my system, right, and I made a small change, so I need to deploy the whole system again because that small change has been made and everything is dependent on everything. Whereas in distributed system, this problem does not come. We'll understand that in the next video. So deployment issues, both in terms of changes and bugs, occur in your monoliths because one small change will affect your whole system. You need to deploy it again, and one bug can break everything because again, everything depends on everything else because we are talking about one box, one system, right? Problem number five, your code complexity. Right now, if I have an MVP, my code is basic. Okay, let's say it's basic. But when I'm scaling, when I'm adding more features, it's becoming more complex, right? And as your system will grow, your code base will become huge. It will become more complex, right? So it will become hard to understand because you're adding everything in one code base. It's not distributed. It will become hard to understand. It will become difficult to maintain this. So basically, if more people are working because the system is growing, you're going to hire more people. So different teams will step on each other's code. You can imagine what kind of a situation that is, right? And you need to handle that. So code complexity is a very, very big problem when it comes to monolith. At certain scale, you cannot handle complexity more than that. And all of these problems, let us revise those ones. Number one, your traffic, because 100 users it will work fine, 10,000 users work fine, a million users system will break, it will become slow, it will become unresponsive, eventually it will crash. Then you have a single point of failure because everything exists in one box. If one server, if that one single server, something happens to it, it crashes, your entire system will crash. You don't have any backup, no failover. Scaling is hard because vertical scaling has limits. You have just one server. The only option you have is vertical scaling. You can upgrade, but how long can you upgrade? You cannot upgrade forever. So vertical scaling has its limits, and hence scaling is difficult when it comes to model. Problem number four, deployment issues. Because everything depends on everything. One small change and you have to deploy the whole system again. One small bug and it can break your whole system. Finally, code complexity. Because your code base right now is small, but as your system will grow, your code base is going to be huge. It's going to be complex. It will become hard to understand and difficult to maintain. And even difficult when teams work together on one single code. Which is why we need to transition to distributed systems. Now, what does it mean when I say that we need to transition to distributed systems? It means that to solve all these problems, we are breaking the monolith. We right now had one big system. Now we are breaking this monolith into distributed systems like this. So we're basically building multiple smaller systems. Instead of one big system, when you create multiple smaller systems, you will be able to solve all these problems. We'll discuss that in the next video too. So now you understand something very important. See, monoliths are not bad. In fact, monolith is where every system begins. They are simple, they are fast to build, and they are perfect when you're just starting out. But as your users are growing, right? As your traffic is growing, as your systems are becoming complex, you cannot rely on monolith. This simplicity of monolith, it will start becoming a limitation. And that is when your engineers, they are forced to ask, how do we scale beyond a single machine? How do we make systems survive failures? Right? When monoliths are transition to distributed systems, you don't transition everything. They are also hybrid systems. That some part of my system will exist like a monolith, some part will exist like distributed system. We'll come to that later as well. So this is depending on the requirements of your system, what your platform does, what your app does, and what do you need to actually change in it. You will ask questions to yourself that how do I scale beyond my single machine and how do I make my system survive the failures it is currently facing, right? And this is where the real shift will happen. And that is exactly what we are going to take in the next video, that is distributed systems, where one server becomes many and one system becomes a network of systems. See you in the next one. Thank you for listening. Happy learning.